Hi guys, okay, so just before we do set difference is what we're going to do today. So before we introduce another symbol, we just make sure that you know all the symbols that we've done so far. So we know that the cardinal number is the number of elements in a set, so it's the hashtag symbol. U will stand for union, N is for intersection, a big capital U is for the universal set, element is written with an E, not an element is an E with a line through it, and A complement is an A with a little dash up there, which means everything outside of A. So as I said, we're moving on to another symbol today, and it is known as the set difference. So it's written as X dash Y, and it's pronounced as X less Y. So is a set of elements that are in X but not in Y. So X less Y is the region coloured yellow. So remember, X is the whole set here, but we're not counting Y, so it's only this section here. So just say if they asked us for Y less X, so that would be all the values that are in Y that are not in X. So we draw our two sets, U stand for universal set, we do our X and our Y. So Y is all of this set here, okay? But Y less X means Y without X. So we cannot have any bit of X in it. So not taking the X into account then, so the Y part would be just this section of the set, which is the Y less X. Okay, so I'm going to do another example showing the set difference, and this time our sets are called A and B. So this part shaded in here is A less B, and this part shaded in is the part of B without A, so it's B less A. So in practical terms, A less B is a set of elements that are in A only. So we just say A only, and then this section here would be known as B only. So it is obvious from the diagram that A less B is not equal to B less A. And I'm going to show you that how they're not equal by doing this example here. So I'll just move it up a bit so to give you room. Just move this up and then move this up so I can have more room. Okay, so we're dealing with this to illustrate the set difference. We take the two sets A and B. So the first thing I'm going to do is I'm going to draw a Venn diagram for A and B. So to draw a Venn diagram, you know now you do your rectangle, and we're dealing with two sets. So I draw two circles, A and B, and this would be the universal set. So the part of the set that we fill in first is always the intersection. So we're going to look at the two sets and see have they anything in common. And we can see 4 is in both of them and 6 is in both of them. So we're going to fill in that part. So 4 and 6 for both of them. So I'm just going to cancel out 4 and 6 and 4 and 6, so then I can see what I'm left with. So what I'm left with then in A is 1, 2, 3 and 5. So I'll write that in. So that's 1, 2, 3 and 5. And what I'm left with in B, we're taking out the 4 and the 6, which I've already counted for, it's 8 and 10. So that would give me 8 and 10. So if I was going to write down then A less B, so that's A only, or the part of A without B. So B is all this guy, so I'm not counting any of these. So I'm not counting the 4 and the 6. So what's in A less B is 1, 2, 3, and 5. So that would just write that down. 1, 2, 3, and 5. And then if we did B less A, so that's B only. So that's the part of B without A, so that's 8 and 10. So that's 8 and 10. So we can clearly see that A less B, so A less B is not equal to B less A. Going to go through another example of that. So we have the set A is 1, 2, 3, 4, 5. The set B is 2, 4, 6, 8. Represent A and B on a Venn diagram and list the elements of A less B and B less A. Okay, so the first thing then that we're going to do is we have to draw a Venn diagram. So I'll draw a Venn diagram. And I have two sets again, A and B. So A, B, label them, and then the whole lot is called the universal set. Okay, so then you're going to fill in what's in common. So what's in common in this one is I have a 2 in A and a 2 in B, and I have a 4 in A and a 4 in B. So this time the intersection is 2 and 4. So what is left then in A? So what's left in A is 1, 3, and 5. So this would be 1, 3, and 5. And what is left in B is 6 and 8. So this is my 6 and my 8. So then A less B and B less A is they want us to find. So A less B is the part of A without B. So that's 1, 3, and 5. So that would give me 1, 3, and 5. And B less A is the part of B without A, which is 6 and 8. We're just writing that, 6 and 8. Okay, going through this example here. So it says, from the given diagram, list the elements of A less B. Okay, so we'll do that first. So A less B, remember, is the part of A without B. So this is all of A, but I can't count B. So all of these guys is gone, especially the B and D. So what's left is A, C, and E. So that would be A, C, and E. Okay, the next one is B less A. Okay, so that is B without A. So this is all of B, but can't take all the elements of A. Have to take out the elements of A. So it's F, G, and H. F, G, and H. Okay, so we have another one here that they're asking. The third part is U less A. Okay, so it's the universal set. So universal set less A. So remember, the universal set is the whole lot, and then I'm taking away A. So no A can be in the answer. So then I'm left with F, G, H, I, and J. So it is F, G, H, I, and J. So it's the universal set, which is the whole lot, less, remember this symbol means less A. So we do not count any of A. The next one then is the universal set less A intersection B. So it's the universal set not taking in without A intersection B. So it's the universal set without the A intersection B part. So remember, the A intersection B part is this guy here, okay, which is the B and D. So that is gone. We cannot count that in. It's a universal set without that. So writing that down then, that would give me the set A, C, E, F, G, H, I, and J. Okay, so that's my I there. So it's the universal set less A intersection B. So we do not write down A intersection B. Okay, so in this example then, we just have a combination of all the symbols that we've done so far. So we just go through it. So it says, examine the given diagram and list the elements of these sets B, A union B, A less B, and A complement. So the first one is B. So remember, B means all the elements that are in B. So this is a set B here that I'm highlighting it. So we'll just write down B then. So B would be the set. And it has 2, 4, 5, 6, and 8. So they're the elements in B. Okay, so the next one then they asked us for A union B. So A union B then. So remember, what does that U stand for? So that stands for union. What does union mean? Means all the elements in A and B. So union is all the elements in A and B that I'm highlighting. So we put them in order. So it'd be 2, 3, 4, 5, 6, 7, and 8. So writing that down then, A union B would be 2, 3, 4, 5, 6, 7, and 8. Okay, so the third question then is A stroke B. So we know that stroke now, we did it today, is set difference. That means A less B. So A less B. So again, what is A less B? It's the part of A only, or A without B. So this is A and B intersections. That's where B is part of A. So we have to take out the B part. So it's only A only. So it's 3 and 7. So that would give me A less B is 3, 7. Okay, and the last question then is the A with that little dash. Remember, that little dash means A complement. So what does that A complement means? It means everything outside of A. So I don't count anything of A. So remember, A, we'll just follow around here, is all that set there. So no element of A is in A complement. So that means everything outside it. So it's 2, 5, 8, and 9. So writing that down then, A complement would be 2, 5, 8, and 9.